Hello guys, today I'm going to be showing you how to do all these problems. First, let me go to show all of my formulas so that you can see that I didn't just type all these numbers in, which I don't understand why people would do that because that takes so much more time than just simply doing the formulas like you're supposed to figure this out. But there's all my formulas. You can obviously see I didn't just plug numbers in like I said. And now let's start with number one. This one is dealing with the worldwide poll over people that want to move because they're not happy with where they're at, and the people that are like, I'm fine with where I'm at, and so I don't want to move. And so you can see on this little pie chart that 71%, which is the orange, the bigger half of it, are the people that want to move, guided by the key down here in the bottom right corner. And the 29 is the people who don't want to. But today, we're going to focus on the orange, the bigger part. Now, if we wanted to break that down into a smaller section, so you could see like what countries are those people who want to move in, then you could look here where I have the United States, Canada, and United Kingdom specifically chosen. Now, if you notice, the 71 and 29, if you add them up, they equal 100. But if you add up the 34, 10, and 10, that's only 54. Obviously not 100. So, if you're wanting to analyze it and understand where all the information is coming from, you cannot start off with what you see in this little chart with the countries. You have to start with the worldwide poll pie chart. And yeah, that's number one. And now let's go on to number two. Number two, I made up a little scenario about a lawn mowing company. And it's a little expensive and kind of outrageously priced, but it's not real life. It's just an example. So it can be whatever I want it to be. So we have to use the formula that's right under the number, g of x equals 3/4 x plus 2. So I made a chart that labeled the minutes from 0 to 24, and then the profit. And the way I got the profit was for 0, I didn't do anything because 0 is 0. If you're not there doing anything, then there's no profit. But if you actually go out there and start working, then it'd be $2. And if you see up here, here's my formula. Instead of x, though, I plugged in 0, the first one. And as it goes down, it applies it to the one right above it. So as you can see, they charge $2 for coming out to the client's house. So this would actually be 2, and it'd be a little different. The chart shows the rising profit as the minutes go by numerically. and it gives a more visual approach. But if you look at it, they're correlating with each other, and they're the same thing. One's just a bunch of numbers, and one's a line on a graph. And now let's go to the next one. Now, if you look right under number 3 over here, you can see the formula to model the sales company. It is P of X equals 4X squared minus 32X minus 240. Now, in the question, the graph in the table on the left shows the sneakers company's projected profit based on the number of sneakers sold. As you can see, the company took a little bit to start making a profit. They initially invested $240 to start it, which is represented by the green moon right here on the graph and right here on the chart. Of course, when you start a new company, you're not going to be a big hit right away, especially if you're like you're just not starting a new company that hasn't ever been made before. So as you can see, the blue moon represents the worst they could do, the farthest that you could be in the hole, so to speak. Eventually, after selling enough sneakers, they will break even and start to make a profit, which is represented by the yellow moon. However, the graph reaches 13 sneakers. It does not break even at 0. They actually made $20, but you can't sell 12 and a half shoes. You can't sell 12 shoes or 12 pairs and then sell just one, because nobody's going to buy just one shoe. That's just not really likely to happen. Now, if we're talking about going to $500 for a profit, it's like the breaking even. It's not going to be exactly the 500. That's a 1 in I don't even know chance, but it's not happening here. If you look at the chart, you could see that at 19 is the closest you can get to it, and it's almost 600. So it's the closest you're going to get to it. But as you can see on the graph, it just keeps getting better and better for the company, and they keep making more and more of a profit, which is good, because that's what you want to do when you start a company. You don't want it to just take forever to reach a higher and higher profit margin. Now, number 4. Over here, under the number, like for all the other ones, here's the formula to model height and feet depending on the time in seconds, which is h of t equals 16 or negative 16 t plus 131 t plus 7. And over here you can see my chart that I labeled time in seconds and height in feet. And if it's 0 seconds, the height is 7 feet. Because if you see over here in the problem, there's a 7 for the starting place. And you can barely see it, but if you look, you can see that it's not on, that first dot is not on the line. It's a little bit above it. And if you look up here, you can see that I have my formula and I plugged in my t, which is 0. And then I have done that for all of these. But you don't necessarily need this negative 10 down there, because if you look on the graph, if you throw a ball up in the air, you're not going to be able to have it go below the ground unless there's like stairs and it's like there's a lower ground level. But if you look on the graph, there is no stairs. So you would not count this 9 seconds and negative 110 feet because you can't go below the ground. It's not possible physically. Going to number 5. This section is representing a resort. The chart explains numerically how long you can stay at the resort for each option, and there are 3 options. There are also these little graphs for those who like to see a picture rather than a bunch of numbers, because some people get confused over numbers, but if they see it in a graph, then it's easier for them to understand and work with. As you can see from the chart, if you want to stay the longest, you should choose option 3, pay 500, and then after each day, you split that in half. So it goes 500, 250, and on and on and on. And you'd stay there for about 16 to 17 days, which is why I highlighted right where 16 is. But if you were looking for more specifically to spend the least amount of money but stay the longest, you'd obviously go with option 1, which would land you spending 9 days there, because once you hit 0, you have to leave. And so you spend more on option 2 to stay there, but you'd only be able to stay there for 5 days. You get to spend 4 more extra days if you pay 200 as a starting amount. So it make more sense to choose option 1 if you want to stay there the longest but spend the least. And then there's my number 6. And I hope that this has helped you